Awesome. Thank you, Ron, for the wonderful introduction. And likewise, I have spoken at quite a few Angelbeat events in the past, and they've always been a great mix of different high caliber speakers, lots of very interesting topics. And I think as you all start to see by the end of today, that the Ron does a very good job about stringing together a bunch of different talk subjects that do mesh very well with one another. So from what I understand, you probably just had a talk about security. And going hand in hand with security is identity. And on AWS, there's a very particular way we go about that, a very particular set of standards. And there's no way I could possibly cover all of identity on AWS in about 40 minutes. But I think there's a very clear sort of hierarchy to identity. And if we can cover the sort of primary building blocks and the philosophy behind that, that will give you a very good primer for getting started with it, and we'll give you a very strong taste for what it looks like for these other services that are downstream and what those will enable. So got about 40 minutes. Really excited to talk to you. And again, my name is Nick Walsh. I'm a developer advocate here at Amazon Web Services. Without further ado, let's get into it. Cool. So you're probably wondering, well, first, why should I care about identity and access management? Aren't, storing my passwords in Post-it notes good enough? And so this sort of brings us back to security before the cloud, right? You have this corporate data center, you have your servers within there, maybe you have your hard drives as well, and you have any sort of inbuilt fault tolerance, everything from fires, floods, hell, hath, and fury, right? And so the issue with this is that you sort of task, one person or a fleet of people to sort of defend the perimeter, so to say. This happens both from a physical perspective, but oftentimes from a credentialing perspective as well, digitally. And I know that, that's a bit of a metaphor there. But what we find is that, this is when you implement this at the perimeter, you sort of have this sort of inside versus outside dichotomy, where there's this very big leap in permissions where you can achieve, getting inside, for lack of a better word. And digitally, we don't really want to enable this. And we also understand that there's a lot of nuance here that we want to be able to implement. I think this will become very obvious in the examples I show. But I think that hopefully at your organizations, you already understand this concept of wanting very fine-grained and tiered access to resources, whether that's users trying to get access to resources, or whether that's resources trying to get access to other resources, like services trying to access a set of data. And so this brings us to sort of the way we do this in the cloud at AWS. We have a service called IAM, Identity Access Management. And in our scenario, we are much happier with the ability to authorize at a resource by resource level. So certain resources can access other resources conditionally, and we can set all of these fine-grained permissions in any way that we want. In addition to that, we don't sort of have either like you have access or you don't have access as a user. Instead, we have much more fine-grained permissions where you can set access for individual people, not just at a, like they have access to service A or B, like RDS or Lambda, but rather we can set the individual functions or the broad sets of permissions like read access or write access for each of these people. And so this is very important, and we think that this is how we want to design systems, and we think that our security profile should match this. So when it comes to security and identity, there's a large suite of services. I'd assume that many of these were covered or at least mentioned in a previous talk, so I'll sort of breeze through them, but I always like to give an overview of where all of this fits in. So first, when we start with identity, we need to be able to have provable ways and programmatic ways for folks and services to, prove to other services that they are of a certain identity, which should then scope them with certain roles and permissions. We have quite a few of them here that enable this, some of which I'll talk today that tie into IAM. Those include AWS SSO, directory service, secrets manager, and ones that I really wish I had time to talk about would be Cognito, and there's actually another one, IAM Access Analyzer, but that may be somewhere else. And so we have all these other ones that sort of tie in addition to identity, things that deal with, detective control, being able to search through logs and perform audits and understand, does someone have access that they maybe shouldn't have? What was a path of escalation here? Can we sort of hunt down that root cause? Additionally, things from, fully purpose-built infrastructure around security, AWS Shield, Systems Manager, VPC on the sort of more passive side for architecting systems, all the way up to things like data protection. So being able to manage your own encryption keys. And there are even features on AWS when it comes to security and identity that may not be standalone identity or security features, but are very, very important for being able to secure your data. One important call out here is like role-based access control for databases. Now, whereas many of your AWS services will have AWS users that access them that we can assign IAM roles and abilities to, essentially, and I'll get to that in a moment. There are other services that actually have at the application level, in the case of a managed database, the ability to assign database user privileges and permissions and scope those down. So lots and lots and lots of ways for us on AWS to be able to assign these privileges. But I'd rather just show you that than just keep telling you about them. For today's agenda, I've got a few points. They're fairly straightforward, and IAM, while it is only one service, that is definitely doing a disservice to only call it like that. It is very important, and it is the bedrock by which we perform properly scoped security and practice the principle of least permissions on Amazon Web Services. And this sort of gets us, IAM, when executed properly, gets us very, very far with limiting the threat profile and practicing proper and safe identity practices on the cloud. So here are the points we're really going to hit today. We're going to go from how to assign these privileges, what they are, to walking through some actual IAM policies. These are the actual definitions for how we assign these roles and privileges to users and services. We'll try to throw in some pro tips if we got time. Again, only about 40 minutes, but I speak quickly. I'm from New York, like Ron said. So I will do my best to be clear, concise, and best of all, you will all be getting these slides after the talk. So if there's anything that I went through too quickly, hopefully you'll be able to catch up there. Okay, cool. So starting off from a sort of human perspective, what are our options for managing identity? We're talking IAM here, but broadly, when we're thinking about accounts, those are sort of the smallest unit. They're sort of the atomic building block of identity in AWS. Inside of any one AWS account, you can have those resources represented by those little colorful blocks. And then sort of on the opposite side, thinking big and sort of working down the chain, we have the AWS organization. Think of this like your entire company. And at your company, you have one master root account that people should not be sharing, but this should be used for performing large organization level actions. Now, it likely makes sense for you to break your organization down into different organizational units, much like how your team has multiple engineering teams, most likely. This abstraction level exists within AWS as well. And now within each of these AWS accounts, again, think of these as individual people. There should be different identities that can scope and role permissions for those people. So much like how if you have a badge and you walk into a building and that badge can give you access to different floors or different closets that store different things based on what you should have access to based on your role and title at work. IAM identities are no different. And so we have these little hard hats here. Think of these as individual different sets of roles. So if I have a badge, it can hold these two different roles and so on and so forth for all of the different users here. Now, every role and set of permissions is going to be different, but just understand that people can hold one or more than one. And we can define these to represent a lot of different things. So for example, if we zoom way in here to an AWS account, this is represented basically by a username, an account ID, and a password. If you try to go to sign into the AWS console, this is essentially all that you need. And this is really great. IAM users, especially when you're starting out, they perform all of these necessary tasks and functions of being able to scope permissions. You need to hold these long-term credentials to be able to designate identity for these individuals. And your very first account has no other options, essentially, to be able to perform this identity federation. So creating the IAM user initially, at least early on, is going to sort of be very necessary. This does scale out, and there are scenarios that we can discuss here around like the sizing for organizational units and sizing for organizations. And in addition to this sort of scale out scenario where you have a lot of different users and a lot of folks at your organization, there are a lot of tools that we also have that make it easier to manage that in addition to what sort of the base console offers for IAM. So an example of signing in with the credentials like this, you may get your own, your organization may have its own sign-in URL. And then with that sign-in URL, any user can provide an account alias, a username, and a password. And if this passes the security check, they can sign in given that user's account, and they will have, for any commands that they execute within the console under that login session, the respective IAM privileges that they've been given. Cool. So next up, we have something called AWS SSO with a user pool. Essentially, what this enables us to do is that instead of folks logging in directly to an AWS account using a username, account ID, and password, instead what they do is they sign into this SSO pool where there's some sort of master account here. We see the one that has root level access to the AWS organization. And this SSO account is, there are credentials related to this SSO account that the organization manages. So if the user passes the authentication check for this SSO account, they may have multiple different ways of authenticating within their organization. And I'll get into some some specific examples of that in just a moment. This SSO account will vend them credentials based on the one of very many username password combinations that they could use. And so the important thing here is that when it comes to SSO, this is a very particular service rather than just a broad class of identity federation options. So there is no, user directory that you're connecting directly to AWS. This is essentially a pool of usernames and passwords that you then delegate to different pools of access tiers. So for example, you can have a pool through SSO for a bunch of usernames and passwords for maybe your software developers or your DBAs. And for each of those, for each of those types of archetypes, you can assign them different roles and privileges accordingly. Now these pools are very helpful, and it's a very easy way for you to assign batches of credentials to a small number of people, or to batches of credentials to groups of contiguous sort of users. So if you have, a innumerable number of different roles where you don't need a ton of different nuances and permissions between the members of the groups, then this one's okay. And again, it's not sort of a one size fits all in the way that I just, could have hinted at there. As your organization grows, you may be moving from one implementation of IAM or identity to another. So, you're not sort of locked in for life on any one of these. And at different points in time, one may be more ideal than others. So the sign-in workflow works a little differently. So instead of providing, an account ID, you get an SSO sign-in portal. And then any given user just simply signs in with their username and password, and that will be mapped to one of the different pools within there. And so when they do sign in with SSO, they sort of have access to one of many pools, or as many pools as they've been assigned access to. Cool. Next up, SSO with Azure AD. So these are examples here that I'm about to give that leverage SSO, but they leverage they allow you to leverage existing user directories that you may have to federate your identity into AWS. So in this case, we're talking about Azure Active Directory sort of as the source of truth. All of the direct, using and password combinations and users that you're bringing in with whatever pre-existing identity methods that you have are essentially being linked in through SSO, whereas SSO is then going to handle assigning and delegating the routes and the privileges for access to you as a user once SSO has handled the identification. So broadly here, what we see is that you bring your own identity management directory, and that handles the approval of deciding whether you are who you say you are. And then it is the role of SSO here on the AWS side to vend the right permissions to you in order to be able to perform the tasks that you need to do. So sort of a separation of responsibilities here. But again, still the same fundamentals that we mentioned before. Broadly, we have, other ways of federating identity here. Instead of going through AWS SSO, if you have Microsoft Active Directory, either on-prem or a managed version of this that's managed through AWS, you can use Active Directory to bypass SSO if that's something that you choose to do. we find that this is something that folks are less likely to go to from scratch and more likely to want to tie in if they already have a very sound existing identity structure around identity in their organization, and they want to be able to simply extend that Active Directory functionality into permissioning in AWS. And so Azure Directory Federation works for this. And so this is what this would look like. You go to sign in to the AWS console, and it will basically reroute you to the Active Directory sign-in to prove your identity. And then once this is complete, you'll be in an AWS session with the ability to perform all the actions that you are scoped to do. So very similar to Azure Active Directory, or to Active Directory here. We see that you can sub in one of many different custom federation providers here. There is a large number of them. You can check the list online to see what the current most supported ones, or running your own third-party SaaS offering to be able to federate that identity. But the schema sort of stays the same, where users prove their identity and perform that identity check with the custom federation provider. And then you give that federation provider the permission to be able to delegate session tokens that are authenticated to essentially give permission for these different tasks. So again, sort of separation of permissions, federation provider approves identity, and then that with an AWS integration enables us to be able to vend them account privileges. Cool. So there's a very quick sort of decision framework, and I've hinted at some of these bullet points as I've been going along. But if you already have some sort of managed existing user directory, something you're very happy with, something that probably ties into other things at your organization, there are lots of easy ways to be able to bring this into the fold when it comes to managing AWS identity, and you don't need to start from scratch. We're trying to build this out so that this doesn't, this is as feature complete every single day, and we're adding more and more integrations. So if there's anything that you're interested in that you don't see as a custom authentication provider or a custom identity provider, please let us know. We'd love to get that on the roadmap. But again, if you don't have any sort of existing user directory, AWS SSO with user pools and IAM users are really great. As we mentioned before, even when you are bringing your own sort of identity providers from abroad, you still are going to need to use IAM users and create those so that we can scope and delegate those permissions, so that you sort of don't get the federation without the ability, without the job of already scoping your users. So I mentioned a lot about people and how we're going to vend permissions to people. But how do we programmatically handle access to data and services for other services? Our applications don't all run on a single EC2 instance with our local file storage attached directly in there. That our ecosystems are a lot more complex than that. And so within an AWS account, we want to be able to restrict access because sort of full openness is the default, if in many ways not at AWS, but we need to be able to either, limit permissions down, or in AWS where we explicitly deny all permissions until they're given, we have to be able to enable those permissions to access other resources. So for example, here you've got an EC2 compute instance. Well, we need to give that permission to be able to access the files that we have on Amazon S3 where we store our files. Likewise, a Lambda function needs to be able to have the right permissions to read or write to a DynamoDB database. So that it can perform those key value lookups, or again, write new data points to our database. So when we're creating these roles for non-human access, we understand at AWS that this interface should look a little bit different than the way that you're scoping permissions for humans. And so we have a lot of these pre-baked sort of boilerplates for assigning or for crafting these roles for a service that we want to assign it to. It's going to be called the principal, and for the given target that it will be able to access. So when we're creating an IAM role here at the top, you see that there's a few different tabs, or those 4 buttons we can click. Instead of creating for another AWS account, we can select an AWS service. We can select the service that's going to use the role, in this case, either EC2 or Lambda, and then we can select the destination and how we define the policy. So let's get into that. We know we have a good idea of when we need IAM policies for both people and services, but let's show you what it looks like to make them. So when you go into the AWS console, you go into IAM, you have this whole list of policies here, and it's sorted alphabetically. And essentially, there are going to be a large number of different policies for every single service that exists. It differs depending on the level of granularity that is sort of extended at the infrastructure level. But things like read access, things like write access. Here we see a few for Alexa, the ability for a business to do device setup, the ability for a business to have full access, which encompasses all of the features. Oh, my Alexa device just went off in the room. Sorry about that. And then here we have, some other things like read-only access, network profile. Again, we want IAM policies to be very granular, and then it is easy for us to assign a large number of permissions by either using the full access feature or by adding each of the respective functionalities that we need. The issue we're trying to avoid is to avoid over assigning permissions, because this is where things become attack vectors in our application stack, where if either a rogue employee or a compromised piece of infrastructure, is taken over by a malicious actor, this will have permissions to do things that we otherwise would not want it to be able to do. Much like how you don't give out, master keys to everybody for a physical location, or why you don't give, keys to in your neighborhood. Your key to your house doesn't also the key open the doors to your neighbor's doors just by accident. We want to sort of follow the same philosophy. I don't have a dedicated slide to it, but this really comes down to the principle of least permissions. Resources and individuals at your organization should only be assigned the exact permissions that they need to operate with the services and other accounts that they need, and no more than that. We know it's sometimes easier to over-assign, and then we don't run into any permissions errors. But in the long run, this is kind of short-sighted. And we know that, while it doesn't happen by accident, assigning privileges in the right way at AWS, if we can create these tools that enable you to do that, that we know that customers care about security and identity, and they'll be able to implement this. And this talk is hopefully going to help get you along the way. So when we're thinking about trying to craft a policy, this one is going to be one of the most simple examples we can go through. This is an administrative policy. It's got essentially as few little elements in here as possible. Let's start here at the top. We have the policy ARN. This is going to be the Amazon resource number. Essentially, this is a unique identifier for this resource. You can see if you sort of go from left to right, you have that it's an AWS entity. It exists in IAM. It is an AWS managed policy in that it is one that AWS manages. You did not have to create this. This is one of the pre-built ones that we provide. And it has unique ID, administrator access. This is the full root access to everything in your AWS account, as it says in the description. And we can see in here, if you sort of blow past version, the statement is that we are enacting an effect, which is to allow. We have allow and deny. And then we have action, where we can then filter by the full list of actions any AWS account could provide. Here we listed star, which means all of them. And then lastly, we have resource. So we can filter by the action and then which resources in terms of either a unique ID for a resource, like a individual database with ID, ABC, or you can specifically list in there, all Amazon RDS, so all relational databases, right? Here we have a star for both. So this is essentially a policy that grants permissions to allow someone to take any action on any resource. This is simply listed here in JSON. Now, that is sort of the nuclear IAM policy, and we don't expect you to be vending that to many people. But that's sort of the first step by which we can go down and step through all of these more nuanced examples. As we look here, this is a read-only policy, and you can see there under actions, things like get, list, describe, search. Nowhere in here do we have concepts like writing data. And so typically writing is something you'd want to lock down. Even reading is something you want to lock down as well. But this sort of sets the stage. So broadly, within your account, these are going to be two of the most common delineations in IAM roles and privileges. You're going to want some level of administrative access for whatever pieces of infrastructure a certain user is responsible for. Say if you're a database admin, it makes sense for you to have access and read and write permissions and the ability to spin up or spin down infrastructure for your databases. But it may not make sense for you to also have, the ability to provision a bunch of instances or ephemeral cloud functions, if that's sort of outside of the scope of where your engineering team runs the stack. but it may make sense for you to have read permissions to be able to get access to that data and to perform tests on that data. So again, everyone sort of has not just the resources they want to touch, but the roles and the actions they want to perform on them, and we can sort of delineate those across the organization. So let's talk a little bit about authorization in AWS. So we have a given user represented by this hard hat there on the left. We have an S3 bucket represented by the little bucket icon over there. And I did mention before that we want to practice the principle of least permissions. So when we're trying to say, okay, we've confirmed this user's identity, now we're trying to authorize, do they have access to a given action or a given resource? And so to make it easier for you to practice the principle of least permissions, when it comes to AWS, any IAM user is by default not given permission for anything until you give permission to them. So essentially think of it like, they start the job, they don't have any keys until you give them keys. I don't mean keys in the programmatic sense necessarily here, but that is another way to sort of look at that. So they want to access an S3 bucket. And these little tiles here on the right can represent different IAM policies that we may have attached to their account. Now, these, upon query time, imagine this is someone who opens the console. Let's keep it simple. We won't use the SDK or anything yet. They open the console, they go to S3, and they want to see some of the organization's S3 buckets. Now, there may be some policies that are applied to their account. Now, we have to walk through sort of how those policies interact with one another, because sometimes those policies and roles that user has assumed could conflict with one another. A user may also both be have the DevOps role at their organization and the software engineering role, and some policies may grant one or both permissions to each. We want to see what this looks like. So the way we go through this sort of hierarchy of rules is as follows. If any policy denies access that user has, then that user is automatically denied access. So if regardless of downstream, whether there's another policy that allows, or if there's, maybe this is applied accidentally, it doesn't matter. If they inherit a role that explicitly denies, then they're automatically denied. And so this sort of supersedes everything. And we think this, is sort of in line with the way we want to think about permissions. Now, below that, if there is an allow policy and there is not a blatant deny policy, then the user is allowed access to a resource. Access denied sort of templates are, again, typically sort of like a secondary check. They're not always prevalent, again, because by design, if a user does not have an explicit allow, they're not allowed to access something. It's not very common for you to see access denied templates across everything. And this sort of makes sense, right? There are hundreds and thousands of permissions across hundreds of services. It would be a little silly for us to have to require users to explicitly deny access to 99% of those and then write the allows for the small number. So deny by default. You can have explicit deny once your organization starts growing and the number of roles you start implementing starts growing. But allow is sort of what will open the door for them. And again, because this is all denied by default, if there is no allow statement, even if you haven't denied them, access is denied. And this sort of this trend will continue regardless of what services you want to use. So in this example, we have two policies. They can intersect, allow, deny. I think it's just for the sake of the diagram, but yeah. Cool. So if one denies them, ultimately they get denied access to that resource. So I gave a sort of, very boilerplate, very baseline example before, but let's think about some other policies. So if we want to read and write data from DynamoDB, again, I mentioned that the policy itself defines what the principal is going to have, or the assignee of the role or the policy will have the ability to do. In this case, we have an EC2 instance, again, virtual cloud server. It is assigned the IAM role represented by the hard hat, and we want that to be able to read and write data to our DynamoDB NoSQL database. So what that policy will look like can be something like this: effect allow, action star, and resource star. But hold up, this isn't just going to assign access to Dynamo for the EC2 to write to DynamoDB. It definitely will, because those permissions are in there, but you're essentially assigning the keys to the castle for anything on AWS to this EC2 instance, and that's a problem. We're assigning all actions, so this isn't just scoped to reading and writing to a database table. This can even delete EC2 instances. That's kind of scary. And for all resources, well, this can do anything for not just DynamoDB. Someone could compromise your account and spin up a bunch of Bitcoin mining servers. But we don't want we want to avoid that. We don't want people to delete our data or any of that. So this doesn't practice the principle of least permission. And this again would not exist by default. By default, this policy would not exist there, and a user would have to go in and add this root access to the EC2 instance, and this would make me very sad to see. So how can we make this better? Well, first we can scope it to, from the action side. We can say that, okay, well, for actions, actions aren't just simply read or write, but they're scoped to given sets of resources. So the reading for DynamoDB is different than the reading for RDS, even when we're not talking about a given resource here. So we can scope that by only DynamoDB actions. But this still isn't perfect. We were giving this all DynamoDB actions, but we only do want to read and write. And so what this means is that this EC2 instance would actually be able to spin up or spin down entire DynamoDB tables or perform other sort of higher level infrastructure tasks that we don't necessarily want to assign to EC2. Again, this is just maybe an application or a test instance. We don't want it to be able to perform large changes to our stack. And let's say that assuming our actions are scoped to DynamoDB, we can do this on all resources. But at the end of the day, does it make sense for this EC2 instance to have access to every single table at our organization? Well, probably not, right? Our application probably has specific dev or test tables, and we'd like to be able to scope on that. So I'm going to give this one another sad emoji or sad face. So let's get even better here. We can take the specific actions we want, sort of work bottoms up, and say, okay, well, DynamoDB has this get item and this put item, and that exactly represents reading and writing our data. Wonderful. So we're looking good here. We've made a lot of improvements, and that action really maps exactly what we want. But again, we have some progress to be made on the resource, so we get a little flat face. When we look through the documentation, we dig through here, and we can see all the actions, resources, and condition keys. We can find get item here, much like what we saw before. And we see that one of the things that we can actually sort on here is a given table. So let's do that right here. So for resource, before we had star, so this would be any DynamoDB instance or any resource instance essentially that can take the DynamoDB actions, which is inherently just DynamoDB. But there are some meta services that can accept that as well. So it's important to scope here. And so again, you have a specific table. You want this EC2 instance to have these permissions to write to this table. And we could assign that by giving the given ARN for that DynamoDB table. So we have specific actions for getting and putting items or reading and writing items. And we have a specific table that we give this access to. Now, the benefit of being able to have this very specific pared down and nuanced permission is that for this role that we've created, this IAM role that enables reading and writing to a specific table, we've assigned it to this EC2 instance, but we can now assign this role to any other services or individuals that need to perform these exact same actions for this exact table. And so when crafted intelligently and with the principle of these permissions, these IAM roles don't have to be recreated over and over and over again for every single user, but instead can be vended additionally to a large number of users or resources. This one passes the test for me, and I think many people would be very, very happy with this. When we want to talk about the table, as I mentioned before, this is again under the documentation. You could see the resource parameter has this as one of the abilities or as one of the sort of keys to be able to filter by. When we're looking at the documentation, again, there's lots of other information here for how you can start to craft these these policies for your the different resources you may have. I talked about DynamoDB here, but you may have many other different types of resources you're going to want to apply these permissions to. So following this sort of formula and template there, this is what that breaks out to. Okay, so how this is actually sort of working under the hood. When the EC2 instance reaches out to DynamoDB, there is an authorization check. This happens for any resource that's going to try to make a request or a person that tries to make a request here. And before any action is taken on sort of at the application level, it first has to be authenticated. And so if you try to do DynamoDB.put item with this table and this ID, what's going to happen is it's going to inspect the IAM policy or that the EC2 instance currently has. And it's going to say, okay, well, this instance has these permissions. Well, those actions are valid for the action that's being performed here. And then we have to check if AWS checks if it has access to that given resource. And so because each of those sort of check out, this would be allowed. It's important to note that the first policy that we mentioned, the fully permissioned one, would work as well here. But again, that is granting it way too many permissions. So we wanted to narrow that down. Okay, here's another example, but with a user. So you have, Jane, she just started your company. You've assigned her the IAM permissions to be able to spin up some test servers, and we want them to be able to get some EC2 instances. So we've given them the rules that should allow them to do that. So which policies should Jane have? Well, we think that we want to scope those down to maybe EC2. And maybe we want to have some specific EC2 instance types. We don't want them to be able to spin up a bunch of GPU instances that could be expensive and not fit for the tasks that they're working on. So there's a few that we could work with here. Examples being EC2 run instances. And we have some other ways we can filter this and narrow this down by sort of a logical around string equaling different instance types. If you've worked with EC2 before, you know that there's a whole spectrum of compute across all sort of different ways of optimizing your infrastructure. And so we can actually enumerate those ones that we do want to allow here. And again, each service is going to have different similar sorts of methods of granularity here. So now we can improve this a little bit further. So here we have this applying to any sort of resource, right? Even though the action is EC2 run instances. But the reality is that oftentimes if there's a meta service that enables or sort of builds on top of EC2, if we don't enumerate that this is explicitly for the EC2 base service, there are scenarios in which this action can be valid for something like Amazon SageMaker, for example. And so don't think of this as something that can be scary, but rather be very, very specific in what you want, and you will likely be able to see the results mapping that as closely as you expect. Now we can even go down further, and we can, within EC2 running instances, we can also add the ability to map this to particular subnets, security groups, key pairs, and so on, if we want even more levels of granularity. This one passes. This is a good one. So when this person goes into the console, they try to launch. The console is a GUI for these underlying API calls that happen under the hood, and it's passing along their key name, their subnet ID, the security group IDs, and so on and so forth. The image ID for the instance they want to open, the instance type, and EC2 will perform this authorization check, or IAM will perform this authorization check to see if you have the permissions to perform the action you're trying to perform. And if, for this instance type, we see that, this checks out, T3 micro is included there. And then we see for this image ID, if we give them permissions for all image IDs or OSs for their virtual servers, but with the one that they've requested, this definitely fits in here. Key pair will match, and each resource gets authorized independently. If any one of these fails, the entire action fails. So again, principle of these permissions, it wouldn't make sense to let the execution go through and just, allow it to spin up with a different operating system or a different image by default. So no, like if the user's action atomically doesn't have all permissions, then it's denied. Okay, next up we have preventing unencrypted writes to S3. This is an example where, you may have, let's say, an open bucket or a lockdown bucket, regardless. You want to make sure that these, the only requests that are valid to send to it are encrypted. So we have a user here, IAM policy, bucket with security functionality on it, or this encryption requirement on it. What we can do here is we can do an explicit deny. So we can make our bucket more permissive, and we can instead put a IAM policy to deny a given user and say that this user cannot upload files to S3 if they are not here represented by the string not equals if exists, this AWS encryption key ID for Amazon KMS, key management system. So this is a way of explicitly denying a particular user if you have maybe broader permissions open for the rest of your organization, but you want to restrict them for a particular user or set of services. And again, so, this is obviously just JSON, and these are flags like string not equals if exists. And these are interpreted sort of on the fly as the requests go down the wire by IAM. So can I write my encrypted data? We also want to allow access to S3, right? So we can provide deny permissions to that bucket if it's not encrypted. But sort of spoiler here, if we never allowed that person permissions to write to S3 to begin with, they wouldn't actually be able to write that anyway. So you start to see here where security, especially when you're trying to get the fine-grained permissions right, even at first glance, if you think you have the permissions in the AWS scenario, you're likely not going to run into a scenario where you're overly permissive unless you're being very heavy-handed with assigning these permissions. But instead, it'll take you a little bit sometimes to be able to craft the exact scope of permissions to do the thing that you want to do. But again, this is good practice in the long run. As we also go down the chain here, we see there was something else wrong with our policy. So we have let's say we're uploading encrypted something that's encrypted. Let's say we have access to that bucket, but guess what? We're using server-side, we're using KMS managed encryption. So for this AWS user to actually be able to have access to that key, that encryption key, we need to make sure that they've explicitly been granted permission to have access to that KMS key, to generate that key when that account was created, probably, but also to decrypt that key. So you see here all of the checks that sort of come into play to be able to make that possible. Okay, I promise I won't throw around too many different snafus, and I don't have all that much time left. So I'm gonna try to fly through the rest of these slides. I want to be respectful for the speakers after me, but I know that this is, something that's very valuable to all of you. So you want to terminate instances in your project. You have someone who works and is able to manage those instances. And let's say that they work on blue team, and blue team has their delegated instances for them, and red team has their delegated instances for the things that they work on. So we want to be able to give an allow permission, and we can have these custom resource tags where even though the EC2 instances from a, metadata perspective, or from a technical perspective, are identical, and the only thing that's different is the applications that we were running on them or the lines of ownership, we can create these custom metadata tags to be able to then perform scoping for IAM actions, so that we don't have to give broad permissions to EC2, so that team blue would mess around with team red's instances. We can see here that, you go into the docs, you go into EC2, resource tag is one of the parameters in here, and that tag key that, again, is custom designed by you is something that you can sort of define. So summary of sort of what that breaks down to, authorizations perform this string matching, and IAM takes care of that for you. You simply define what the policies are for what you are allowing and denying permission for. It only performs an allow if there is a matching allow statement. If there's an explicit deny, it will deny that. And by default, permissions are off unless you explicitly grant them. You can use these custom tags in IAM policy to sort of map these organizational, not silos, but, delineations and team structures you have. And there are lots of other additional authorization controls in addition to IAM. I mentioned, I think it was RBAC before, role-based access control for databases. So at the application level, you can control access. But when we're thinking from the infrastructure level at the top, sometimes IAM may be all that is necessary, but it really depends. Okay, let's see what we have here. I don't have a whole bunch of time, so I'm actually going to very quickly skip through all of this because I want to make sure I can get to any Q&A. But this is, again, going to be available in the slide deck that I provide to you. And this is essentially going over vending permissions from one AWS account to allow access to users in another account. I mentioned before, the principal can be a user or a service inside of an organization. And here we're showing the principal being another AWS account, giving them and extending them permissions to resources that can be inside of your account. So that if you have this master database that exists, has to be owned by an individual account, all the other accounts that your organization can access that in a programmatic way. So we may only want read-only access for that. And we can assign that to the entire organization. If there's a resource, maybe a database isn't a good fit for that. But let's say something like a repository for all of the files for S3, everyone should be able to have access to that at your company. We can assign that at the principal organizational level. Maybe you want to spin up or provision, resources in another account. Well, this is possible as well. So essentially, you have DynamoDB access as a parameter inside of that, or as a role inside of that AWS account that has permissions for that table. And then the other AWS account can actually assume the role of that IAM role that lives in the secondary account. And the way that we do this is that we essentially craft a principal policy in the let's say our database account that is going to allow access to this IAM role that someone else can assume access to. So you sort of need this, the permissions that are vended to account 111.223. This needs to be definitively defined inside of 4456. So this is where essentially we're defining trust between the two different accounts. Cross-account access in some instances becomes necessary. So it obviously introduces some complexity, but it's something that is very valuable. This is where some of the meta management tools around IAM, like organizations, organizational units, help to sort of gate off these permissions in a logical way and to make it easier and more streamlined to vend these credentials in a streamlined way without sort of hitting the nuclear button and giving everyone admin privileges. Just going to fly through this a little bit.
Hey, Nicholas?
Yeah.
It's Ron Gerber, because I know we're getting short, and I know you want to have some Q&A. Maybe you could at least comment on this. One of the questions came from Timothy, and how do you integrate multi-factor logon into your identity management? And he was questioning about ADFS, which I'm wondering might stand for Active Directory. Maybe you could just comment a little bit about multi-factor login capabilities?
Yeah, so IAM supports MFA, multi-factor authentication. There are a handful of different ways that you can go about this, everything from a virtual MFA device to some of these physical security keys that you plug into your device. There's a whole table in our documentation, and I'll try and grab the link that actually talks about how you can enable these secondary forms of authentication. So again, if you're using exclusively, IAM users to sign in, you can do that. A lot of folks also, if you want to federate identity, that works as well. And whatever, multi-factor authentication works there during that identity check, that would be applied there. I'll get the link so that you can see all of the different sort of tiers of compatibility with different MFA options. Does that sound good?
Yes, and I will make sure that all of the attendees get answers to that.
Great. I just looked it up real quick. It's I can't paste the link in right here, but it's aws.amazon.com/IAM/features/MFA. I'll post it in chat as soon as my talk is done when I can exit from the PowerPoint. Cool. I'm just going to click through a bunch of this. This is going to demonstrate some other examples of doing cross-region or multi-region setups. But briefly, if we cover sort of in recap everything that we just talked about, we want to be able to vend credentials to humans. We want to be able to have this authorization be made in a way that's understandable and that is very deliberate. We don't want these systems to behave in ways that we don't sort of anticipate. And so hopefully it was very clear in the way that AWS sort of interprets these permissions and roles. And I hope you learned a thing or two about being able to construct good and solid IAM policies. There's some of these other controls that I mentioned before, like role-based access control. IAM can be just the tip of the iceberg. You can go down and lots of other services have their own nuanced and purpose-built ways of limiting access. And then lastly, there's a lot that a lot of organizations are doing to build on top of these APIs, in the same way that you create accounts and vend these permissions. You don't always have to do that through the console. Riot Games has this really cool open source tool that they've built called the Cloud Inquisitor. It enables them to actually vend and create AWS user accounts with the right permissions for their new onboarding hires or when folks change teams in a fully self-service way. So really cool project. Check that out. If you're interested in learning more about security and identity, we have lots from training and certification here at AWS. Link, obviously, there leading up to the Certified Security Specialist exam. But I know I'm out of time. I'd love to get some questions if Ron will allow it. But thank you again. My name is Nick Walsh, developer advocate here at AWS.